Hello, and welcome to the informational session on the LaSalle Avenue Corridor Resiliency Plan. Over the next several minutes, we'll walk you through the intent of the project, the analysis that was performed as part of the study, and show the results of the analysis and the proposed mitigation measures. To provide some context to the origins of this current study, the Joint Base Langley Eustis Air Force Base LaSalle Entry Control Facility serves over 30 to 35% of the traffic into the base. The gate can be accessed through a 1.5-mile long LaSalle Avenue roadway that stretches between Mercury Boulevard and the entry control facility. The LaSalle Avenue traverses through two major bridges over the New Market Creek and the Back River. Due to the traffic volume passing through the gate and the gate's proximity to the water bodies, which are tidally influenced and impacted by the sea level rise, the 2018 Joint Land Use Study Addendum has recommended that the LaSalle corridor be evaluated for flood potential and provide recommendations to mitigate the impact of the recurrent flooding and future sea level rise. As part of this presentation, we will review the study and analysis areas, the criteria that were utilized in performing the analysis, and the analysis findings. We will also review the proposed mitigation measures and the next steps. So to orient ourselves, the study and area analysis area boundaries. The star that we see on top of the map in the middle of your screen represents the LaSalle Entry Control Facility location. The highlighted gray line represents the study area, which encompasses roughly the 1.5-mile long LaSalle Avenue that stretches between Mercury Boulevard and the entry control facility. The white line represents the analysis area. As you can see, the analysis area encompasses a much wider area. This was required to capture the impact of the New Market Creek and the Back River as they are tidally influenced. For those of us who are not entirely familiar with the study and the analysis area, I would like us to get oriented by highlighting some landmarks. We'll go from the bottom of the screen to the top. We're looking at the Coliseum, Home Depot, Air Power Park, New Market Creek, Boo Williams Sportsplex, Back River, and JBLE Air Force Base entrance, the entry control facility. Now that we have oriented ourselves with the analysis area, let us look at the criteria for the analysis. As I mentioned earlier in the presentation, the primary reason for performing this analysis is to identify the impact of flooding on the LaSalle Avenue corridor. There are several potential causes for flooding, but for the purposes of this analysis, we looked at three main causes: rainfall, sea level rise, and tailwater conditions. To better understand the causes, let us look at them graphically. This is just only a graphical interpretation. Rainfall. We utilize the 24-hour storm intensity depths as published by the National Oceanic and Atmospheric Administration, shortly called as NOAA. The published atlas was in the year of 2000 and it was called the Atlas 14. Next, sea level rise. For planning purposes, we utilized three scenarios: 1.5 foot, 3 foot, and 4.5 foot, as recommended by the Hampton Roads Planning District Commission. And finally, tailwater. So what is tailwater? Tailwater elevation is the elevation of the water surface in the downstream channel or creek or the river. We will discuss more about this later on in the presentation. Now that we have selected our criteria to actually perform the analysis, we need definitive numbers, such as what is the 24-hour storm depth for various written periods, what tailwater to use, etc. We will look at those numbers now. Rainfall. So we have various written periods that we looked at, mainly 4. For a 10-year period, the 24-hour intensity we used was 5.53. For a 25-year, it was 6.83 inches. And for a 50-year, it's 8.05 inches. And then 100-year, it was 9.35 inches. Tailwater. Remember, earlier we talked about the tailwater? It is the water surface elevation downstream of where we are trying to discharge the stormwater to. For the purposes of this study, we took the data that was measured at Buckrow Beach over several storms during 2018 to 2020. A representative sample of those storms are listed here. For example, for Hurricane Florence, which happened on September 10th, 2018, the peak tide elevation was 3.6 feet. And for Hurricane Dorian, which happened almost a year later, in September 6, 2019, the peak tide elevation was 4.2. And various different nor'easters recorded anywhere between 3.6 to 3.8 feet. So the average peak tide elevation that we ended up using in our modeling or for the analysis was 3.6 feet. And finally, the three sea level rise conditions that we saw earlier, 1.5 foot, 3 foot, and 4.5 foot. For this analysis, we wanted to look at the impact, not just any one of these criteria, but a combination of all these three. The reason being, the likelihood of all these three happening at once is very high. So let us see what we found out in our analysis. Again, to orient ourselves, over the next several slides, we will be looking at flood inundation mapping for various scenarios. The bottom left-hand corner, where you see the arrow, will show us the flood inundation condition that we are looking at. We will review the various rainfall scenario results for each sea level rise condition. The first being sunny day flooding, where there is no rainfall. Then we will move to 10-year flooding with various sea level rise scenarios, so on and so forth. The deep blue on the map indicates significant flooding with inundation over 3 foot, and the light blue indicates half a foot of flooding or less. While we are looking at these flood inundation mapping, it is important for us to remember that these are not existing conditions. These are future scenarios, the timeline of which is not clearly predictable. Now we are looking at sunny day, 3 foot sea level rise. Sunny day with 4.5 foot sea level rise. So this is the flooding that is caused just by the tide coming in to the land. Now we are looking at the 10-year storm, 1.5 foot sea level rise. 25-year storm with a 1.5 foot sea level rise. 50-year storm with a 1.5 foot sea level rise. And 100-year storm with 1.5 foot sea level rise. 10-year storm with 3 foot sea level rise. 25-year storm with 3 foot sea level rise. 50-year storm with 3 foot sea level rise. And 100-year storm with 3 foot sea level rise. And finally, 10-year storm with 4.5 foot sea level rise. 25-year storm with 4.5 foot sea level rise. 50-year storm with 4.5 foot sea level rise. And 100-year storm with 4.5 foot sea level rise. Now that we have seen what the flood inundation boundaries look like, we are going to look at the impact of the flood inundation on our roadway infrastructure within the analysis area. These results are limited to highest rainfall scenario we analyzed, which is the 100-year storm, overlaid with the various tailwaters. As for the street flooding legend, the light blue indicates the flooding less than 4 inches, and the deep red indicates the flooding over 12 inches or 1 foot and above. So going through these graphics, the 100-year storm with 1.5 foot sea level rise, the 100-year storm with 3 foot sea level rise, and the 100-year storm with a 4.5-foot sea level rise. I'll just pause here just so that we could sink in what we are looking at. The impact of a 4.5-foot sea level rise on our roadway network within the analysis area. Moving on. So what does all this mean to the LaSalle Avenue corridor itself? Because that was the question that we started with. Orienting ourselves to the LaSalle Avenue profile that we are looking at right now. Right side of the screen is the Joint Base Langley Eustis Air Force Base entry control facility. The black line, while not to scale, indicates the profile of the LaSalle Avenue from Mercury Boulevard to the entry control facility, with the dashed red lines indicating the significant crossings that the roadway makes over the 1.5-mile stretch. The highest water surface elevation that the LaSalle Avenue study corridor experiences under various sea level rise conditions are 4 foot in 1.5-foot sea level rise condition, 5.5 foot in 3 foot sea level rise condition, and 7 foot in 4.5-foot sea level rise condition. So we barely cross over. The lowest elevation on the LaSalle Avenue corridor is 6.43 feet. It is also important to note that the significant flooding that we have seen in the previous slides in the Riverdale neighborhood is because of the bridge openings under the LaSalle Avenue at New Market Creek and Back River. Additionally, there are 2 of the culverts draining the stormwater from the neighborhood into the New Market Creek. These culverts expose the neighborhood to flooding. Remember this point, as we will revisit in a second when we talk about the proposed mitigation measures. Now that we know what the impacts are of the rainfall plus sea level rise plus tailwater on the LaSalle Avenue corridor and the surrounding neighborhoods, let us look at the interventions or the proposed mitigation measures. We had a criteria for the mitigation measures too. The objective of these mitigation measures was to provide critical corridor resiliency, reduce impact on the Langley entry control facility gate operations, diminish forces of water impact on built environment, exactly as what we talked about, the rainfall, sea level rise, and tailwater, mitigate risks to JBLE Langley mission readiness, and increasing public safety in the event of water impact, and protect economic resources. Now talking about the proposed mitigation measures. Remember what we said about the analysis findings, that these are future scenarios and the exact timeline of when those conditions are to be arriving at us. I want to point out that most of the mitigation measures that are being proposed will be implemented in a phased manner, and the benefits are incremental. We will discuss in a short while how these mitigation measures are implemented incrementally as courses of action. So let us see the mitigation measures being proposed. And I would like you to take a look as the flags come along. The colors of them will change based upon the phase. Raising Mercury Boulevard, the first project. LaSalle Floodwall South. LaSalle Floodwall North. Raise LaSalle Avenue North. Raise Tidal Creek Bridge. Raise LaSalle Avenue South. Box culverts and sluice gates. Tidal Creek Floodgate. Tidal Creek Pump Station. Replace New Market Creek Bridge. New Market Creek Floodgate. Replace Mercury Boulevard Bridge. Mercury Boulevard Floodgate. Mercury Boulevard Pump Station. And finally, New Market Creek Trail. I'll pause here again so that we can sink in all that we have just seen. And to summarize, there are total 16 different projects and 6 phases are being proposed as part of the mitigation measures. If we were to look at the mitigation measures as courses of actions, short form, COA, how do they look like? The COA 2, which has 9 projects, will almost provide protection to the LaSalle Avenue corridor and some benefit to the Riverdale neighborhood. With the execution of the COA number 3 measures, which are the Tidal Creek floodgate and the pump station, the LaSalle Avenue corridor will completely be secure, be protected from the sea level rise impacts of 1.5 foot, 3 foot, and 4.5 foot sea level rise, and will allow for the uninterrupted access to the Air Force Base and make the access to the base resilient to flooding. COA number 4, which has 4 projects, will complete the protection of the Riverdale neighborhood and adding additional benefit to the entire analysis area. We will look at those improvements in just a moment. It is also to be noted that the phases and the courses of action that are being recommended are completely reconfigurable as the priorities and then the available funding change. Now, we are going to look at the specific positive impact provided by the mitigation measures that are being proposed in COAs 3 and 4. We're going to look at the flood mitigation with and without the mitigation measures. So this is the flooding. What we are looking at is without the mitigation measures. And in this figure, the gray represents the flooding extent of before the mitigation measures. As you see, there is a significant improvement in the entire analysis area. It is also important to note that no neighborhood gets impacted adversely. And just for effect, I will go back one more time. This is without the mitigation measures. And what we are looking at is with the mitigation measures. And the mitigation measures are primarily the floodgates, the pump stations, the various flood walls, and then the backflow preventers on the 2 culverts. To provide a visual of what the floodgates will look like, we have created 3D renderings. Currently, we are looking at the floodgate being proposed on Back River at the LaSalle entry control facility. And the same rendering through a different angle. And then on Back River, we are proposing sluice gates. These are the gates that move up and down. Now we are looking at the visual of New Market Creek floodgate. Keeping in mind the current day recreational navigation that happens along the stretch of the New Market Creek, a special type of floodgates called crossed gates are being recommended here that will allow for the navigation to occur. The intent of either the floodgate on Back River or on the New Market Creek is to operate them during a severe storm event or during a high tide event, but then mostly at all other times to leave it open. We are looking at a different rendering, and I just wanted to point out that the entry control facility is to the right of your screen. So thanks for sticking through the presentation. So where are we going from here? What are the next steps? The next steps are for the joint process between the joint base Langley Eustis and the city of the Hampton to come together to discuss, review the comments received from the community, the residents, and all the other stakeholders that are involved as part of this project. Refine proposed projects and implementation order, as we discussed earlier. Develop updated implementation strategy and timeline based upon the funding available, and explore and align with the funding opportunities. So with that, I thank you all for taking the time to listening in on the presentation. We look forward to seeing you at the public information sessions on March 10th and March 15th. Thank you.